Saxon's Calculus Lesson 94 is about logarithmic differentiation. Now if you look at this example from example 1, you see that we could do this with the quotient rule, but they want to teach you a different way of doing these problems by using logs. So that's what we're going to walk through here, is this different way. So we're going to begin by natural logging all parts of this equation. So this is going to go to the natural log of y, and it will equal, and because the 2 is the exponent, it's multiplying in front of the natural log of x. And because this stuff is in the denominator, it's going to minus, and again, that exponent with a 4 is going to go in front of the natural log of 3x plus 2. And now our goal is to, of course, solve for dy over dx. And to do that, we first have to derive each of these parts. So, of course, natural log of y goes to 1 over y dy equals, and then the 2 is multiplying with, and natural log goes to 1 over x, so we're going to write that as 2 over x dx minus, and the 4 is multiplying, and the 3x plus 2 is heading to the denominator, but we also have to derive the 3x plus 2 part, which goes to a 3, which multiplies up top, and of course that's still dx. And our goal is to solve dy over dx. So if I pull the dx out of both and divide it over here, then I've got dy over dx. That means I have to get rid of the y part on this side, so I'm going to end up multiplying y with the rest of this stuff that is being simplified. So that would give us 2 over x minus 12 over 3x plus 2. So we're in good shape there, and we've solved for dy over dx. However, our original y was this fraction, and it needs to be substituted back in. So dy over dx equals x squared over 3x plus 2 to the 4th power multiplying with, and then I was debating, should I put the y with the rest of that or not? No, I've already substituted the y. That's this. Duh. 2 over x minus 12 over 3x plus 2. And then they want you to realize that this pattern will happen every single time. So it says we made the mental condition that x will be greater than 0. That's why they use 3x plus 2 in that example. And that x would be positive, so that when you did the natural log of 3x plus 2 and the natural log of x would be defined. The result we get is the same result we would have gotten if we had used the quotient rule for derivatives, and is therefore valid for any value of x that does not cause a denominator of the final result to equal 0. So their final conclusion then is that you can do dy over dx is always whatever the original function was, multiplying with the sum of fractions. Sorry, it takes a while to write that. Okay, so now that we kind of have that, let's look at example 2. Y equals x cubed square root x squared plus 1 all over x plus 2 to the 6th power, and we are asked to find dy over dx. So to do that, we are going to natural log all of the parts. So we have here natural log of y dy equals, and this goes to 3 natural log of x. Now this is technically x squared plus 1 to the 1/2 put in its fraction format. So then that gives us plus, sorry, because they were multiplying, that's a plus in between, 1/2 with x squared plus natural log of 1/2 x squared plus 1 And then minus, because it's in the bottom, 6 becomes in front, natural log of x plus 2. Yes, okay. Now, work that out, making it 1 over y dy. I instinctively wrote that there. It's actually not there. Equals, and then 3 over x plus the 1/2 is multiplying here with 1 over x squared. I want to be putting that in the bottom, x squared plus 1, because it was 1 over that, yes. And then when I derived this part, I get 2x, so the 2's will cancel off and just leave me the x minus, okay, so now that's our 6 over top of x plus 2, because that went to 1 over x plus 2. Oh, and I failed to write my dx and dx with those. Okay, now dy over dx equals, and we're multiplying y with everything, so I might as well go ahead and substitute back in my original x cubed square root of x squared plus 1 over the x plus 2 to the 6th, multiplying with, and I pulled the dx from everything and put it underneath already, so that's leaving me 3 over x plus x over x squared plus 1 minus the 6 over x plus 2. I guess I don't really need parentheses with those. And then closing this parenthesis. Now, example 3. Y equals square root x, 3x plus 2 multiplying with x cubed plus 1 to the 4th and 5x minus 3 squared all over x cubed minus 2 to the 5th power, and they want you to find dy over dx. So again, natural log the y equals natural log of, and then of course this was written to the 1/2 just like before, so we're putting our half in front of the natural log of 3x plus 2, and because that was multiplying, it's adding with 4 goes in front, natural log of x cubed plus 1, and then it's still multiplying, so plus 2's going in front, natural log of 5x minus 3, and that was in the bottom, so it's minusing 5 natural log of x cubed minus 2. Make sure you can, oh no, you couldn't see that. Okay. All right, you should be fine now. All right, so then we will go through and do 1 over y dy equals the 1/2 with the 3x plus 2 going to the bottom, and that gives a 3, so that should give us 3 up top, and then plus we have our 4 over top of x cubed plus 1, but that became 3x squared, which makes this then 12x squared. Oh, foo. dx plus, we have our 2 over top of 5x minus 3, but that derives to 5, which makes this top now 10 dx, minus we have the 5 over x cubed minus 2, and that derives to a 3x squared, so 15x squared dx. Okay, then dy over dx equals, and that's going to multiply with the y, so then all of that would need to be rewritten. Square root of 3x plus 2 multiplying with x cubed plus 1 to the fourth, multiplying with 5x minus 3 squared all over the x cubed minus 2 to the fifth, multiplying with, and then this stuff summarized. So that's going to be 3/2. So I started to say here with the 3/2, except that that 2 is in the denominator, so I'm going to leave it 3 up here and then distribute that and make it 6x plus 4 plus, now that's 12 over, okay, there's nothing there that needs fixed, so 12x squared over x cubed plus 1 plus, and again, nothing to change there, 10 over 5x minus 3 minus, and then nothing to change there. So 15x squared over x cubed minus 2, and close that parenthesis. All right, very long, but there we go. Okay, then there is example 4. Y equals x to the x, thankfully it's shorter, find dy over dx. So we're going to natural log the y equals x multiplying in front of natural log of x. Then d, well, 1 over y dy, I'll put it that way, equals, and then the x is acting as our constant, so that's x dx technically, and then plus, because they were multiplying, 1 over x dx. One second, I don't like that x there. No, because the natural log of a constant goes to 1. This should be 1 dx implied. Okay, so that's going to give us dy over dx, because I pulled the dx's and divided it, multiply with the y, which means I'm going to rewrite the x to the x, and then summarization here is 1 plus, and then because that's 1 over x dx, I can go ahead and write that as natural log of x, and that's fine. Okay, that was a very nice and easy short one. And then example 5. Y equals x to the x cubed plus 4. Find dy over dx. So if we natural log the y equals, then our x cubed plus 4 is coming down and multiplying with the natural log of x. And then that's going to be 1, I was waiting where to write it, 1 over y dy equals, and the x cubed plus 4 dx, because it's multiplying plus, I'll have to write it underneath, plus 1 over x dx. I feel like I didn't do, knew I wasn't putting something. I did the natural log part, but I didn't do the fact that this has a 3x squared with it. There we go. Okay. Now put our dy over dx equals, because I separated the dx and put it on the other side, multiplying with the y, which means we're rewriting x to the x cubed plus 4 is multiplying with, and then that is okay. My issue that I'm having here is that I was sort of treating this as a constant here in this step. However, it needs to be separated. And so I feel like it should be writing 3x squared over the x, but then, okay, so what they've done is they've dropped the 3, written that as x squared, and then the 4 as 4 over x because they've natural logged that part as well. So I thought, okay, are they treating this as 3? Okay, let me see that. 3 over top of the natural log of x cubed, which would make it 1 over x cubed. Nope, because see, that doesn't take me to the x squared. I would be leaving it, honestly, I would be leaving it with x cubed plus 4 plus 3x squared natural log of x is how I would write it. But this is how they're writing it. X squared plus 4 over x plus the 3x squared natural log of x as I would have expected. So like I said, I would not have this part. I would have this part as in x cubed plus 4. But I feel like they're trying to do something with the fact that that dx was coming over here, and that's how they've changed it. Anyway, I don't fully get why they have that answer, just to be completely honest. But that's the end of lesson 94.